Hello students, in today's class we are going to learn about trigonometric functions. How we are going to define our functions based on our trigonometric ratios. So far what we learnt in this chapter, very basic thing only we learnt about the angle, how we can measure the angle in degree and radian, the relationship between degree and the radian. That's what we learnt so far. Now only we are getting into the chapter how we are going to define, we are going to see how are we going to define trigonometric functions, right? So far what we learnt in our previous classes, in the sense class 10, we learned how we can define these trigonometric ratios cos theta, sin theta, tan theta on a right angled triangle. So we restricted our angles only on a right angled triangle, right? We dealt with only right angled triangle, and if ABC is a right angled triangle and 90 degree at A, and if B is theta, angle theta, then we know AC is the side opposite to theta and AB is the side adjacent to theta, and we know BC is the hypotenuse, right? If this is a case, then how we defined our cos theta? Cos theta is adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. What is your adjacent? AB divided by BC is your cos theta. Then how we defined our sin theta? Opposite side of theta divided by hypotenuse. Opposite side divided by hypotenuse, which is equals to AC divided by BC. Then what is our tan theta? Tan theta is adjacent side of theta divided by opposite side, or opposite side divided by adjacent side. Tan theta is opposite side divided by adjacent side. It is opposite side divided by adjacent side, that is AC divided by AB, or else tan theta can also be written as sin theta divided by cos theta, right? These are all the basic ratios we learnt in our class 10. We learnt in our class 10. In the sense, we restricted our trigonometric ratios only to a right angled triangle, right? Now in this class what are we going to do? We are going to extend the definition of trigonometric ratios to any angle in terms of radian measure, right? So far we have restricted to the ratio only to a right triangle. Now we are going to extend the definition of all these trigonometric ratios to any angle in terms of radian measure, right? For that what are we going to do? We are going to consider a unit circle. What is meant by unit circle? Radius is 1 unit. So consider a unit circle with center at origin, right? Now let P A comma B, P of A comma B be any point on the circle, any point on the circle, and we have assumed angle AOP equal to x radian. We know whenever we are talking about the angle subtended by the arc length at the center will give you only in the radian measure. Therefore we are assuming the angle as x radian, right? If this is x radian, then what will be the arc length? That is also x. That's what the definition, right? That's what the definition of a radian. What is the definition of the radian says? If the radius is 1 unit and the arc length is also 1 unit, then the angle measured will be 1 radian. That's what the definition of the radian. So if we assume the angle made by the arc at the center with a unit circle is x radian, then the arc length will be x. That's how only we framed our formula also, right? Theta equals to L by R. So theta is x. If theta is equals to L by R. Theta we have assumed it as x. So L divided by radius is 1. So if you cross multiply, length will also be x, right? So what are we going to do? We have considered a unit circle. Unit circle means radius is 1, and we chose a point P A comma B, P of A comma B, in the sense this measurement x coordinate will be A and y coordinate will be B. The distance PM is B and the distance OM is A, right? We have chose a point P in such a way the x distance from O to M is A and P to M is B on the circle. And we have assumed the angle AOP equal to x, then obviously the arc length AP is also x. Now how will you define this all these three ratios to this triangle OMP? Now if you consider triangle OMP is a right triangle, right? OMP is a right triangle. Therefore cos x will be what? Again the definition of cos theta is adjacent by hypotenuse. Now our angle is x, which is the, now see, this is a right triangle and this is 90 degree, therefore this side is your hypotenuse, and which is adjacent to x? Adjacent to x is OM divided by OP. What is the measurement of OM? A. OP is 1, therefore cos x is A. Then what will be sin x then? Sin x is equals to, the definition of sin theta is opposite by hypotenuse. Which is opposite to x now? Which is opposite to x? MP or PM, right? So PM divided by hypotenuse is OP. The measurement is B by 1, which is equals to B. So we got cos x equals to A and sin x equals to B. But if you see OMP, which is a right triangle, so what you know? In a right triangle by Pythagoras theorem, hypotenuse square is equals to sum of the squares of the other two sides. Therefore, OP square equals to OM square plus PM square, right? Now what is your OM? OM square, what is your OM square now? OM, what is the measurement? A, right? So I can write A square plus what is your PM? PM is B, so I can write B square, right? What is your OP? OP is 1, so I can write 1 square. Now A square plus B square equals to 1 square. 1 square is nothing but 1. Now what is our A? A is nothing but cos x, so I can write cos square x plus what is your B? Sin x, so I can write it as sin square x. So we got our first identity, cos square x plus sin square x equals to 1. Hope you have learnt this identity in class 10. Yes, cos square theta plus sin square theta equals to 1. How we got that identity? Based on these results only, right? So far what we did till previous classes, we learnt about trigonometric ratios, but we restricted those trigonometric ratios only to a right triangle. Right? Now what are we going to do? We are going to extend the definition of these trigonometric ratios to any angle in terms of radian measure. So for that we considered a unit circle, which means the radius is 1 unit, and we chose a point P on the circle in such a way its distance from x-axis is B and its distance from y-axis is A. In the sense OM is A units and PM is B units, right? Now, and we have assumed angle AOP as x radian. We have assumed angle AOP equal to x radian. If this is x, then the arc length will also be x. Now we considered this triangle OMP, and which, since it's a right triangle, we, by Pythagoras theorem, this OP square is equals to OM square plus MP square. In the sense 1 equal to A square plus B square. But on the other hand, we defined all these cos theta and sin theta, the trigonometric ratios, to the angle x. If we define the trigonometric ratio to the angle x, what will happen? Cos x is adjacent by hypotenuse, so you will get A by 1, which is nothing but A, and sin x will be opposite by hypotenuse, which is B by 1, which is nothing but B. So we arrived at cos x as A and sin x as B. So we are going to substitute the value of A and B here. So we arrived at the identity cos square x plus sin square x is equals to 1, which is our first identity, first and the basic identity, right? Now if you see, one complete revolution is how much radian, which is 2 pi radian. we already know, right, one complete revolution is 2 pi radian. So what will be the angle of AOB now? Where is AOB? See here, AOB, this complete revolution is 2 pi, therefore AOB is pi by 2. And what is AOC? AOC is pi, another pi by 2, right? So it will become pi. Then what is AOD? What is this angle? Another pi by 2, so it will become 3 pi by 2. Yes, so what is given here? AOB is pi by 2 and AOC is pi, AOD is 3 pi by 2. Now see, this complete revolution, one complete revolution is 2 pi, that we know. From here to here is 2 pi, that we know already. Now therefore AOB till this, how much angle is this? Pi by 2. We know 90 degree. 90 degree is nothing but pi by 2 in radian measure. So this is pi by 2. And what is AOC? AOC means from here to here. How much it is? This is pi by 2, this is another pi by 2. Or else in degree measure we will say 180 degree. In radian measure we will say it's pi. Right? Now AOD from here to here, how much it will be? 3 pi by 2, right? 270 degree, which is nothing but in radian measure 3 pi by 2. When it reaches A again, it will be 2 pi, one complete revolution, right? So these are called quadrant angles. So what is meant by quadrant angles? Integral multiples of pi by 2. Integral multiples of pi by 2. We are keep on multiplying multiples of pi by 2. These multiples of pi by 2 are called as quadrant angles, right? Now let us see the trigonometric ratios for these quadrant angles. Let us define the trigonometric ratios for these quadrant angles. Now what will happen? What is cos 0 now? See, what we got as A when we assumed this angle as x, we got cos A, cos x equals to A, right? When we assumed this as x, what we got? We got cos x equals to A. So A is nothing but the x coordinate of the point, right? And before getting into that, we should know the coordinates of A, B, C, D. We should know the coordinates of A, B, C, D. What is the coordinate of A? 1, 0. This is a point lies on where? X axis, and we know we have considered a unit circle. Therefore, y coordinate will be 0. So 1, 0. What will be the value of B now? What are the coordinates of B? B point lies on y axis, and we know this measurement is 1 because radius is 1 and it lies on y axis, therefore x value will be 0. So 0, 1. What about this C point? C point lies on x axis and we know this is -1, therefore -1, 0. And D point lies on y axis negative side, therefore 0, -1. So now we obtained all the coordinates of A, B, C, D, right? Now what are we going to do? We are going to define the trigonometric ratios for the quadrant angles. What is meant by quadrant angles? Integral multiples of pi by 2. Right, integral multiples of pi by 2, in the sense pi by 2, pi, 3 pi by 2, 2 pi, likewise it goes on. Right. Now before defining all these, let us recall what we learnt: cos x as A and sin x as B, and we know how we got this. Yeah? So A is, if you check, A is nothing but the x coordinate of the point. So using this relation we can define these values. Now if you see cos 0, cos 0 means the angle is 0, in the sense this OA is going to be your initial side and this OA is going to be your terminal side as well. There is no angle at all. It doesn't rotate, it doesnn't revolve. OA is your initial side and OA is going to be your terminal side as well. So there is no angle. Therefore A point is going to be your initial point as well as your terminal point. So what is the x coordinate of A? 1. Therefore cos 0 is going to be 1. Cos 0 is 1. Now the angle is moved till here. It is going to be pi by 2. It is going to be pi by 2. Therefore the terminal point is going to be B. Right. Now what is the x coordinate of b now? 0. Therefore cos pi by 2 is 0. Now again we moved from here to here. Now we reached here, cos pi. Now the terminal point is c. What is the x coordinate of c? Minus 1. So cos pi is going to be minus 1. Now it is going to be 3 pi by 2. So we reached here. What is the x coordinate of d now? 0. So cos 3 pi by 2 is 0. Now again we moved and we reached here. Then it is going to be 2 pi, and here again the terminal point is going to be a only. Therefore the x coordinate is 1. So cos 2 pi is 1. Right? So cos 0 degree is 1, cos pi by 2 is 0, cos pi is minus 1, 3 pi by 2 is 0 and 2 pi is 1. That's how we have defined the quadrant angles. We have defined the trigonometric ratios for the quadrant angles, that is integral multiples of pi by 2. Similarly, now we will find out the sine values. Sine values are nothing but the y coordinates of a, b, c, d respectively. Right? So what are all the y coordinates? Sine 0 is 0. When it reaches here, 1. Pi by 2 is 1. Then when it reaches here, 0 again. Then when it reaches here, minus 1. And when it reaches 2 pi, again it is going to be 0. Right? So when we analyze these values, what we infer? We infer that if x increases or decreases by any integral multiple of 2 pi, the values of sine and cosine functions do not change. Do not change. See, if x increases, keep on increases by any integral multiple of 2 pi, right, the value remains the same. Cos 0 is 1, for 2 pi it again becomes 1. Sin 0 is 0, cosine 2 pi is 0. So when it comes to a rotation of 2 pi, one complete revolution, when it reaches, the value remains the same. Again, if it completes the next revolution, when it comes back to the same position, the value is going to be same. Again and again. So any integral multiple of angle, any integral multiple of 2 pi is going to be there, then the value of the sine function and the cosine function do not change. So you should remember this. Now let us see the inferences out of these. So as I told you, any integral multiple of 2 pi, the sine and the cosine functions do not change. Hope you understood. See, from here we started, and when it reaches the initial point again, the value is not going to change because it is reaching at the initial point, right? So this is true for both cosine and the sine function. So any integral multiple of 2 pi, the values of sine and cosine functions do not change. These are all the basic things which you should remember while solving problems. So understand the concepts properly so that you won't forget, right? So from this, what can we say? Sine 2n pi plus x is equals to sine x, which means if x increases with any integral multiple of 2 pi, hope you understood. Integral multiple of 2 pi means not only for 2 pi, if it is going to be 4 pi, likewise if you substitute n as any integer, any multiple of 2 pi, when it reaches also it is going to be remain same. The value of the sine value is not going to change, not only sine, for cos also. So you should remember this, sine 2n pi plus x equals to sine x for any n belongs to z. Similarly, cos of 2n pi plus x is going to be cos x for any n belongs to z. This is one inference which we got out of this. There is another inference which is sin x equals to 0 if x equals to 0 plus or minus pi plus or minus 2 pi plus or minus 3 pi etc. How you got this? See, analyze the sine values. When are we getting 0? See, at 0 degree, then at pi, then at 2 pi, likewise it goes on. So sin x is 0 if x equals to 0, x equals to pi, x equals to 2 pi, etc. Right? Similarly, when cos becomes 0, at what values cos becomes 0? See, pi by 2, 3 pi by 2, 5 pi by 2, likewise it goes on. So x is equals to plus or minus pi by 2, 3 pi by 2, 5 pi by 2, etc. So how can we say this in general? Sin x will become 0 if x value is an integral multiple of pi, because this is true for all multiples of pi. But cos x will become 0 only when x is an odd integral multiple of pi by 2, because we are not getting for all multiples of pi by 2, 3 pi by 2, 5 pi by 2, only odd multiples we are getting, right? Because cos pi is not 0, cos pi is actually minus 1, right? So this is not true. So for cos value, when it will become 0, only during the odd integral multiples of pi by 2. I repeat, cos x will become 0 only when x takes the odd integral multiple of pi by 2. This is called as odd integral multiple of pi by 2. How we will denote odd number? 2n plus 1. If we say 2n, it is even number, right? So when it will become odd integral? Even when it is 2n plus 1. Likewise only we will denote an odd number, right? So it is 2n plus 1 into pi by 2. So when comes to sin value, when sin value will become 0? For all multiples of pi. So it is denoted as n pi. Right? So these two things you have to remember. And so far what we learned one first and important identity, cos square x plus sin square x equals to 1, and we learned how we got this identity. Then we learned two important inferences. One is, during the integral multiples of 2 pi, the sine function and the cosine function do not change in their values. The second one is, the sine value becomes 0 during integral multiple of x, and the cosine value will become 0 during odd integral multiple of x. So these are all the three things which we learned so far and which you also should remember, right? Now using the definition of cos and sine, now we will define other trigonometric functions. What are all the other trigonometric functions? Cosec x, cosecant x. Cosec x is the reciprocal of sin x. How you will remember? Cosec starts with c. So it is not a reciprocal of cos x, it's opposite, sine. This is how only I will remember. So I am giving you clue. If you are okay with that, you can remember in that way also. Cosec starts with c, so it's reciprocal of its opposite, sine. Secant starts with s, so it's a reciprocal of its opposite, cos. Right? Now cosec x is the reciprocal of sin x, so 1 by sin x. When we have the denominator, when we have a rational or a fraction, immediately what we will say? We will state this with the condition that the denominator should not be equal to 0. Now the denominator is sin x, so immediately we will say sin x should not be equal to 0. When sin x will become 0? Just now we learnt sin value will become 0 when x has an integral multiple of pi. So that's why we have written x should not be equal to n pi, where n is any integer. Right? Then secant x is 1 by cos x. So 1 by cos x, and immediately we will say cos x should not be equal to 0. When cos value will become 0? When x is a odd integral multiple of pi by 2. Odd integral multiple of pi by 2. So x is not equal to 2n plus 1 pi by 2, where n is an integer. And we know already tan x is sin x by cos x. Immediately we have cos x in the denominator, so we should give the appropriate condition. Cot x is cos x by sin x, or we can say cot x is 1 by tan x. Cot x is the reciprocal of tan x, right? So using the naming also you can get tan cot. So cot x is the reciprocal of tan. So when we got sin x in the denominator, we can say x should not be equals to n pi. Alright. These are all the other trigonometric functions which we defined in terms of cos and sine. Now we will come back to the identity. One basic identity only we learnt, sin square x plus cos square x equals to 1. Using this, let us obtain the remaining two identities you might have learnt in class 10. What are all those two identities? 1 plus tan square x equals to secant square x, 1 plus cot square x is equals to cosec square x. Let us see how we can arrive at. Now this is our basic identity, right? Now divide throughout by cos square x, what will happen? Sin square x divided by cos square x plus cos square x divided by cos square x equals to 1 by cos square x. Now what is sin square x divided by cos square x is nothing but tan square x plus this is 1, which is equals to 1 by cos is secant x. So it will become secant square x. So 1 plus tan square x equals to secant square x is your next identity, right? Similarly, we can obtain our third identity by dividing our first identity by sin square x. If we divide completely by sin square x, what will happen? Sin square x divided by sin square x plus cos square x divided by sin square x equals to 1 divided by sin square x. So this will become 1 plus cos by sin is nothing but cot square x. Reciprocal of sin is cosec square x. So 1 plus cot square x is equals to cosec square x is your third identity, right? This is your first identity. We have divided 1 by sin cos square x, we got our second identity 1 plus tan square x equals to secant square x, and when we divide throughout by sin square x, we got our third identity 1 plus cot square x is equals to cosec square x. These are the three basic identities, right? Now let us see the values of these trigonometric functions for some standard angles. Till 0 to 90 degree you know already. Now we have written in terms of radian, so nothing different in that. 0 degree and pi by 2 is nothing but 90 degree, right? And what is pi by 4? 45. Pi by 6 is 30 degree and pi by 3 is 60 degree. From 0 to 90 degree you have learnt in your class 10. So sine value will start from 0 to 1 and cos value from 1 to 0. This how only you can remember. Sine starts from 0 and pi by 2 value is 1. 0 to 1. Cos value is from 1 to 0. The opposite of that, right? Then tan is nothing but there is fraction of sine and cos. 0 by 1 will become 0. 1 by 2 divided by root 3 by 2 will become 1 by root 3. The division, if you divide these two values, you will get tan values, because the definition of tan theta is sin theta by cos theta. Now how we will remember the in between values? In between values I will remember in this way: 0 to 1. Therefore after 0 you have to take the half of 1, which is half. 0, half, and 45 degree is 1 by root 2, then root 3 by 2. Slowly you have to increase, or else you can find the angle because we are doing it in the radian, right? So you remember in this way: 0 to 1, then after 0 1 by 2, 1 by root 2, root 3 by 2, then 1. Then cos value is just the opposite of that. So this one should come here: 1, root 3 by 2, 1 by root 2, 1 by 2, 0. So I am explaining till 90 degree. You might have learnt in last class. I am just recalling. Sine value is from 0 to 1. Cos value is from 1 to 0. Sine value slowly you have to increase: half, 1 by root 2, root 3 by 2. Then cos value is the reciprocal of, not reciprocal, the reverse of those values. So 1, root 3 by 2, 1 by root 2, 1 by 2, 0. And if you see at 45 degree, the cos and the sine value remains the same, 1 by root 2. Now tan is nothing but sine divided by cos. So 0 by 1 is 0. 1 by 2 divided by root 3 by 2, what will happen? 1 by root 3. 1 by root 2 divided by 1 by root 2, you will get 1. Root 3 by 2 divided by 1 by 2, you will get root 3. 2 will get cancelled. 1 divided by 0, 0 in the denominator, which is not defined, therefore it is not defined, right? Now come back to the next part. After pi by 2 is pi. Pi means what? 180 degree, then 3 pi by 2, then 2 pi. 3 pi by 2 is 270 degree. right? So this is 180, 270 and this is 360 degree. Now just now we discussed these values, pi, 3 pi by 2, 2 pi and all. So what is sin pi? Sin pi is 0 and we have learnt when it reaches 2 pi the value of the sine and the cos function is going to remain same. There is no change. So sin 0 is 0, so sin 2 pi is also 0. Cos 0 is 1, so cos 2 pi is also 1. Tan 0 is 0, therefore tan 2 pi is also 0. And we have also seen the sine value will remain 0 during the integral multiples of pi. Therefore, this is sin pi is 0, right? And we have seen cos value will become 0 during the odd integral multiples of pi by 2. That's why 3 pi by 2 cos value is 0 and even in 1 pi by 2. Pi by 2 means 1 time pi by 2, right? That is also 0, right? So in this way you can remember the sine values and cos values for the remaining angles pi, 3 pi by 2 and 2 pi. Anyhow, you have to remember the entire table, have some clues and hints and remember the values for all these standard angles, right? So using these values we can very well write the values of cosec and secant, because we know cosec function is nothing but the reciprocal of sine and secant is the reciprocal of cos and cot is the reciprocal of tan. So for all these angles we can very well write cosec, secant and cot values, right? So it is enough if you remember this entire table. So what we learnt in today's class so far, we started with the trigonometric functions. We extended the trigonometric functions to any angle with the radian measure, right? And we arrived at the first identity cos square x plus sin square x equals to 1. Then what we did, we analyzed the trigonometric ratios or trigonometric functions for all these quadrant angles, which are all called quadrant angles, integral multiples of pi by 2. Then we have stated the cos and sine value for all the integral multiples, and analyzing these values we found two inferences. We came to a conclusion saying that the sine value and the cos value will remain same in every integral multiple of 2 pi. That is, there is no change in the sine and the cos functions in the any integral multiple of 2 pi. Thus we have stated it as sine of 2n pi plus x equals to sin x and cos of 2n pi plus x equals to cos x. Similarly, we have arrived at another conclusion which says sine value becomes 0 during any integral multiple of pi, cos value will become 0 during any odd integral multiple of pi by 2. Right? Then what we learnt other trigonometric functions based on sine and cos definition. Then we have arrived at another two basic identity, 1 plus tan square x equals to secant square x, 1 plus cot square x equal to cosec square x. Then we arrived at the standard values of the standard angles, the trigonometric values of the standard angles in a table. So out of today's class, what are all the things you have to remember, starting from the two inferences, when the sine value and cos value will become 0 and what will happen to the cos and sine value in the integral multiple of 2 pi, then three basic identities, and then this table you have to remember, right? So learn all these things, don't blindly by heart the values or by heart the things, definitely you will forget. So understand the concept and then learn it, so forever you won't forget, right? So with this, let us wind up today's class. Hope you understood. If you have any doubts, contact me. In the next class we will see how the sign of the trigonometric functions are going to change and what is the range and the domain of the trigonometric functions and few other concepts in the next class, right? Thank you, students.